Hello everyone, I am Balaji Rao. Welcome to BR Maths class. I am very happy to inform you that I am starting a new batch for JEE. This course is valid until JEE Advanced Examination 2026. First chapter called Basic Mathematics. In that, first one is number system. You already know about this number system. What are natural numbers, what are real numbers, what are rational numbers, irrational numbers, all those things. And some interesting facts in this number system we'll discuss first, which are useful further. Okay. First topic is number system. Next one is algebraic identities. This is very interesting actually. When you did Olympiad mathematics, then you will see many interesting questions on algebraic identities, right? A cube plus b cube, a plus b whole cube, a square minus b square, a cube minus b cube, like so many identities are there. We'll discuss all those algebraic identities and we'll do practice problems also related to algebraic identities. Next, inequalities, especially linear inequalities, and there is a method called wavy curve method. We'll use very frequently while solving JEE problems. So we'll do inequalities also in basic mathematics. Next, logarithms. This is the area many students they don't touch it in 10th standard, and directly we'll use in plus 1 plus 2 also. This logarithmic special chapter is not there, but we use these properties very frequently. So logarithm definition, logarithm graph, properties of logarithms, all those things we will learn here. And basic graphs. In trigonometry, you know, sin x, cos x, tan x graphs, you already those graphs, and some modulus functions. And based on, suppose mod x graph is there, mod x plus a graph, how it will be, mod x minus a graph, how it will be, modulus of x minus a graph, how it will be, modulus of x plus a graph, how it will be. Those simple graphs knowledge that are needed. So we'll discuss those things. And next, coordinate geometry, coordinate system, actually not full coordinate geometry, it's a coordinate system. You already learned about coordinate system, but very interesting factors are there in coordinate system. Those things we will discuss. Not only that, locus of a point, which is not covered in your plus 1 plus 2, locus of a point, transformation of axis also we will touch in this coordinate system, right? So first we'll start with the chapter called number system. What are the things you are going to learn in this number system? First, you will learn about what are real numbers, what are complex numbers. You know, number system is mainly divided into two types. What are real numbers, what are complex numbers, all those things we will discuss. Proper fraction, improper fraction, continued fraction. What is meant by proper fraction, what is meant by improper fraction, continued fraction, how to calculate the value of continued fraction, all those things we will learn in this number system. Prime numbers, what are prime numbers, what are composite numbers, what are twin prime numbers, what are co-prime numbers, and what are the interesting factors you must know from these prime numbers. Those things also we learn in this number system. Numbers to remember, numbers to remember. Suppose suddenly they'll ask 3 cube value is what? 3 cube is okay. 6 cube value is what? 6 cube value 216. We won't calculate immediately, right? So cubes, square root of 6 is what? Square root of 6 is 2.4, right? Like that, you need to remember few values. Root 3 value 1.732. What are the numbers we need to remember? And numbers to remember, in this some multiplication tricks are also there. Suppose 75 whole square is there. How you will calculate this 75 whole square? There is a trick. Suppose 65 whole square is there. How you will calculate this, right? 120 whole square is there. How you will calculate this? For this, all those things we will learn in this number to remember. Symbols, some useful symbols are there. Sigma notation, pi notation, product notation, all those things we will learn. Factorial notation, we use this in permutations and combination. However, we will discuss this notation also. Divisibility rules, there is a chapter called permutations and combinations. There directly they will ask questions when a number is divisible by 3. Suppose they will ask 1, 4, 3, 2, 1. Is this number is divisible by 3? The rules are there. All those things we will discuss. Square of a number trick, that's we discussed here. Square of a number trick, right? Suppose 40 square or 43 square, 65 whole square, right? 98 whole square. How we will calculate these numbers? There is a trick for that. Next, practice problems related to this number system, and at last DPP. I'll give DPP. And this course is available on YouTube, but that notes, this DPP solutions, all those things are available for a paid course. Creating these videos takes so much of time, so much of efforts. So you can buy this course in my app, Android app, BR Maths Class, for a very nominal price, right? This course is valid till 2026 JEE Advanced exam is over. Okay. So without much delay, let's begin this class. This number system is mainly divided into two types. One is real numbers, another one is complex numbers. Complex numbers are also called imaginary numbers. Real numbers. What are real numbers? Instead of directly talking about real numbers, we need to talk about natural numbers, whole numbers, integers, rational numbers, irrational numbers. After that only we can talk about real numbers, right? So I'll just quickly recall. Don't worry, I know that you all know about real numbers, but as a part of basic mathematics, I'll just quickly recall what are real numbers. Okay. Before discussing about real numbers, we need to discuss what are natural numbers. Natural numbers are denoted by n, right? You all know counting numbers are known as natural numbers. 1, 2, 3, 4, like this. These are all natural numbers. Is 0 is a natural number? No, 0 is not a natural number. Okay. Whole numbers. What are whole numbers? For natural numbers, you include 0. 0, 1, 2, 3, 4, and so on. Right? These are the whole numbers. Is 100 is a natural number? Yes, 100 is a natural number. Is 100 is a whole number? Yes, 100 is a whole number. And here one point you need to know. Natural numbers are subset of whole numbers. Subset means what? Again, all natural numbers are whole numbers. Yes or no? Suppose 4 you take. 4 is a natural number. 4 is a whole number also. Subset. In sets chapter you learn about this subset. Is very simple. Whatever the elements are there in this set, this is called set notation. Whatever the numbers are there in this set, all those elements will be in this set, right? All natural numbers are whole numbers. This notation, whatever I written here, this notation is known as subset. That means all natural numbers are whole numbers. Okay. Natural numbers, whole numbers. Next, integers. Integers are denoted by I or Z. In some books, they'll denote it by Z also. Integers. Okay. What are integers? In integers, positive integers are also there, negative integers are also there, 0 is also there, right? So here integers I'll write like this: 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on, right? Here, do not confuse. Plus or minus 3 means here two numbers are there. One is plus 3, another one is minus 3. Okay. Is 3 is an integer? Yes. Is minus 3 is an integer? Yes. Is minus 1 is an integer? Yes. Okay. So here, these are the integers. In this, again, positive integers. Suppose if they ask I plus positive integers, what are positive integers? Positive integers means 1, 2, 3, like that you will get. These are the positive integers. You can observe here, positive integers are nothing but natural numbers. Okay. Next, negative integers. What are negative integers? Minus 1, minus 2, minus 3, and so on. These are all negative integers. Okay. And one more thing here you need to know, non-negative integers, not negative, non-negative integers. Answer, what are non-negative integers? Non-negative means not negative. Okay, I'll start writing that set. Non-negative, not negative. 0 is negative. 0 is neither negative nor positive. So 0 comes under non-negative numbers. Non-negative. 1, 2, 3, 4, 5. What all these things are? These are all non-negative integers. You can observe in this set, whatever numbers I written, they are all not negative. 0 is not negative. 0 is not positive also. Similarly, non-positive integers. What is meant by non-positive integers? Not positive. In this set, what elements will come? 0 is not positive, right? -1 is not positive. -2 is not positive. -3 is not positive, right? What are these numbers? These are all non-positive integers. So I hope you understand, right? Integers, positive integers, negative integers, non-positive integers, non-negative integers. Okay. Next, rational numbers. What are rational numbers? A numbers which are in the form of p by q, where p comma q are integers and the denominator q is not equal to 0. This is the general definition what we learned till 10th standard. Rational numbers. A numbers which are in the form of p by q are called rational numbers. We'll get a nice discussion about rational numbers here. Few points, interesting things what you need to know. Till now everybody knows, right, the number which is in the form of p by q, where p and q are integers, q not equal to 0. What are integers? Here you see these are the integers. Okay. For example, you take now 2 by 3. This number is in the form of p by q and both are integers. So this is a rational number. Okay. Now -4 divided by 5 is a rational number. What you need to check? This is an integer. -4 is an integer. 5 is an integer. Yes. And this denominator is not equal to 0. So -4 by 5, it is a rational number. Okay. And here they see natural numbers. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. All integers are rational numbers. For example, you take 5. 5 is an integer. Is 5 is a rational number? Yes, because this can be written as 5 by 1. Both observe numerator, denominator, both are integers and denominator not equal to 0. So 5 is an integer, 5 is a rational number also. So whatever the order I am writing here, they are all subset. That means all natural numbers are whole numbers, all natural numbers are integers, all natural numbers are rational numbers. Whole numbers, all whole numbers are integers, all whole numbers are rational, right? So here, what are the interesting things you need to know? How many rational numbers are there? First point. How many rational numbers are there? Infinitely many rational numbers are there. Between two rational numbers, how many rational numbers are there? Try to catch this point, what I am trying to say. Between two rational numbers, how many rational numbers are there? Between two rational numbers, infinitely many rational numbers are there. Right? I'll discuss this. See, I considered a number line. Here, -1 is there. Here, 4 is there. You can take rational numbers 2 by 3 and whatever two numbers randomly. I pick two numbers. -1 is a rational number or not? Yes, -1 is a rational number. 4 is a rational number or not? Yes, 4 can be written as 4 by 1. It is a rational number. Between these two rational numbers, how many rational numbers are there? Between these two rational numbers, infinitely many rational numbers are there. How to prove this? See, what I'll do, I'll take a midpoint of these two numbers. Midpoint of these two rational numbers. What is the middle point? Middle point is, you can calculate like this: -1 plus 4 divided by 2. This is what? 3 by 2. 3 by 2 is a rational number or not? Yes, 3 by 2 is a rational number. So here I found one rational number between these two rational numbers. -1 is a rational number, 4 is a rational number. Okay. Now between -1 and 3 by 2, we can find one more rational number. How you will find that midpoint of these two? -1 plus 3 by 2 divided by 2. So what is this? -2 plus 3 divided by 4. 3 minus 2 is what? 1 divided by 4. 1 by 4. 1 by 4 is there. Yes, 1 by 4 is there here. In between these two rational numbers, I found one more rational number, 1 by 4, right? Between these two numbers, we can find another rational number. How? -1 plus 1 by 4 divided by 2. So this is nothing but minus 4 plus 1 divided by 8. That is minus 3 divided by 8. Minus 3 divided by 8. This procedure continues. This procedure continues. So what the point you learn? Between two rational numbers, there are infinitely many rational numbers are there. This is important. We'll discuss the same thing when we discuss about real numbers. Actually, we are discussing about real numbers only. All these are all real numbers. You will come to know very soon. Between two rational numbers, there are infinitely many rational numbers. From this only, we'll get that between two real numbers, there are infinitely many real numbers. Okay, right. So what is the interesting point you learn related to rational numbers? See, mathematics is all about not learning the things quickly. Try to understand the concept neatly. Try to understand the concept neatly. Do decent number of problems. Quality of the problems is important. Not number of problems, not at all important. Quantity is not important. Quality is important, right? So what are rational numbers? You already know what are rational numbers. A numbers which are in the form of p by q, where p and q are integers, q not equal to 0 are called integers. What the interesting point you know about rational numbers is, between two rational numbers there exist infinitely many rational numbers. Okay, and all integers are rational numbers. All integers are rational numbers. Is converse is true? Converse means all rational numbers are integers? No, all rational numbers are not integers. For example, 3 by 2 is a rational number. 3 by 2 is not an integer, right? Converse is not true. All rational numbers, all all rational numbers are not integers. Some rationals are obviously integers. Suppose you take 4, 4 is rational, 4 is integer also. But here what is the statement? All integers are rational numbers, but all rational numbers are not integers. Good. Next, irrational numbers. Irrational numbers are denoted by q dash or q complement. In sets chapter you will learn all those things. Complement of q, right? Q dash. What are irrational numbers? The numbers which are not rational. The numbers which are not rational are called irrational numbers. Here I am not going to discuss about terminating numbers, non-terminating numbers. We don't need those things. However, whenever necessary, I'll discuss that point. Right? The numbers which are not rational. For example, you take root 2. Root 2 is not rational. Why root 2 is not rational? What? See, root 2 can be written as root 2 divided by 1. You may say that it is in the form of p by q. But root 2 is not an integer, right? So clearly it is not a rational number. Root 2, root 5, right? 2 plus root 3, right? 1 by root 3. These are all not rational. These are all irrational numbers, right? The numbers which are not rational are called irrational numbers. Okay, good. Cube root of 10. This type of numbers are not rational numbers. These are called irrational numbers. These are all irrational. Okay. So actually where we started to discuss about real numbers. What are real numbers? Union of all these numbers are known as real numbers. Bit confusing, right? Bit confusing. Here you need to know that, see, this set, natural numbers set, is a subset of whole numbers. Whole numbers subset of integers. Integers subset of rational numbers. That means in this, which set is bigger set? Rational numbers, because all natural numbers are rational numbers, all integers are rational numbers. Rational numbers, irrational numbers. Irrational numbers are denoted by q dash. Union of rational and irrational. Union of rational and irrational means whatever the numbers you can mark on the number line. For example, we are discussing about real numbers, right? On the number line, from where to where number line will be there? From minus infinity to plus infinity, number line will be there. Here 0 will be there. Suppose 1.414. See, root 2 value, if you check root 2 value is 1.414. In JE level, we'll remember this, right? Root 2 value is 1.414. Can we mark this on the number line? Yes, 1.414. Somewhere here you will get. That is root 2, right? You want to mark 10.5. Yes, we can mark somewhere here, it will be the 10.5, right? Whatever the numbers we can mark on the number line are known as real numbers. See, how we say real numbers means, see, first point, you can say real numbers like this. Union of rational and irrational numbers are called real numbers. Real numbers are denoted by R. We use real numbers very frequently in JE, especially functions chapter. You must know what are real numbers. What are real numbers? Union of rational and irrational numbers are known as real numbers. Union, this comes in sets chapter. In case if you don't know what is union, rational numbers, irrational numbers together known as real numbers. Rational numbers, irrational numbers together known as real numbers. How we represent real numbers? See, what are real numbers means? In all these ways you can mention. Union of rational and irrational numbers are known as real numbers. Or you can say like this: rational numbers, irrational numbers together known as real numbers. Or you can say like this: numbers on the number line are called real numbers. Or real numbers will also represent in interval form, right? This we will learn in inequalities. About intervals we will learn in inequalities chapter more clearly. See, in on the what is the number line? This is the number line. Number line is in between this minus infinity plus infinity. See, whatever number, see, this indicates that all the numbers in between minus infinity and plus infinity are known as real numbers. This is interval notation. We'll discuss more clearly about intervals in inequalities topic, third topic in basic mathematics. Okay. So, I hope you understand what are real numbers. Actually, what we are learning about number system. Okay, number system, real numbers. Number system is mainly divided into two types: real numbers and complex numbers. What are real numbers? Real numbers are the union of rational and irrational numbers, right? Suppose 2 by 3 is a real number. Yes, 2 by 3 is a real number. Root 2 is a real number. Yes, root 2 is a real number. Cube root of 5, is it a real number? Yes, if you calculate this, you will get some number. It is a real number, right? So, real numbers are the union of rational and irrational numbers. Now, complex numbers. What are complex numbers? What are complex numbers? The numbers which are in the form of a plus ib. The numbers which are in the form of a plus ib are called complex numbers. The numbers which are in the form of a plus ib are called complex number. For example, 2 plus, here you need to know few things. What are a and b? A and b are real numbers and I is square root of minus 1. A and b are real numbers and I is square root of minus 1. Okay. For example, actually from where all these things are developed, in real system, root over minus 4 is what? In real system, square root of a negative number is not defined. We write it as it is not defined, right? So square root of minus 4 is what? Square root of minus 4 we can write like this. Minus 4 can be written like this. This can be written as minus 1 into root over minus 1 into root 4. Here they introduced this Euler notation I. Root over minus 1 they write it as I, right? So what is this? This is I into root 4 is 2, right? This is I into 2, or simply we write it as 2I. The number which is in the form of a plus ib, suppose 2i is in this form. Look at this. Actually 2i is there. 2i can be written as 0 plus I into 2, right? This is in the form of a plus ib only. So the numbers which are in the form of a plus ib are called complex numbers, where a and b are real numbers. I is square root of minus 1. I'll take an example. 2 plus 3i. Is a complex number? Complex numbers are also known as imaginary numbers, right? 2 plus 3i. You see, this complex number chapter is there in class 11th. But you need to know what is number system actually. Number system mainly two types: real numbers, complex numbers. That's why just discussing, to know basics of complex numbers. I'm not going in depth of this. In class 11th, detailed chapter is there on complex numbers. We'll learn over there. 2 plus 3i, it is in the form of a plus ib. So it's a complex number. Now here you need to know one thing here. 4 is a complex number. Actually 4 is a real number, right? 4 is a real number. We know that 4 is a real number. Is 4 is a complex number? What are complex numbers which are in this form? Yes, 4 is a real number, but 4 is complex number also, because 4 can be written as 4 plus I into 0. You see here, a plus ib. A is a real number, b is a real number, right? So this is a 4 is a real number, 4 is a complex number also, right? 4 is just a complex number. 4 is not imaginary number. That's why complex numbers, imaginary numbers in detail. Suppose this number is there. This number is complex number. This number is not real number. This number is complex number. This number is real number also. Here one point is very clear. Every real number is a complex number. Every real number is a complex number. Suppose you take 2 by 3. 2 by 3 is a real number. Yes. Is a complex number? Yes. This can be written like this. 2 plus 2 by 3 plus I into 0. 2 by 3 is a complex number. All real numbers are complex numbers. All complex numbers are real? No. Suppose 2 plus 3i is there. This is complex number, but this is not real, right? And here a few points you need to know. We may use suddenly about this. I is what? Square root of minus 1. Okay. I square is what? I square is minus 1. Okay. I cube is what? I cube can be written as I square into I. I square is what? Minus 1. Minus 1 into I, that is minus I. I cube is minus I. I power 4. I power 4 can be written as I square whole square. I square value is what? Minus 1. Minus 1 whole square. Minus 1 whole square is what? 1. So I value is square root of minus 1. I square value is minus 1. I cube value is minus I. I power 4 value is 1. So many things are there to discuss about complex numbers. Just introduction I given. What are complex numbers? What is the interesting fact about complex numbers? All real numbers are complex numbers, but all complex numbers are not real. Here you need to know one very important point. Natural numbers, all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers, all rational numbers are real numbers, all real numbers are complex numbers. So which set is bigger means complex number. This is the superior. This is the biggest set, complex numbers. All real numbers are complex numbers, but all complex numbers are not real. These are all subsets. See, all natural numbers are complex numbers. Yes. All whole numbers are complex numbers. Whole number is a complex number. Yes. Integers are complex numbers. Rational numbers are complex numbers. Real numbers are complex numbers. All real numbers are complex numbers. I hope it is enough to discuss about number system now. Now we will learn about proper fraction, improper fraction, continued fraction, and how we will calculate continued fraction value. Proper fraction. What is proper fraction? Fraction, same like p by q form. If numerator is less than denominator, then we call it as a proper fraction. Numerator is less than denominator, then we call it as a proper fraction. Improper fraction. Improper fraction is what? Is simple. Numerator is greater than denominator. For example, 5 by 3. Numerator is greater than denominator. Then it is improper fraction. Proper fraction, improper fraction. These are easy, right? Continued fraction. What is continued fraction? How we will calculate its value? Continued fraction. See, continued fraction is 2 plus 2 divided by 2 plus 2 divided by 2 plus. If it continues like this, right, it is called continued fraction. Okay. Not only 2, you can, in place of 2, you can write any other number like 1, 3, 5, something like that, or any rational number also. This is known as continued fraction. How we will calculate this value? Suppose if you want to calculate this value, how you will calculate? We'll take one problem related to this. Okay, you observe this. This is the continued fraction. How to find this value? You can see here like this, it will be there. So here what you need to observe, where it is repeating, continuously repeating, you observe it started with 1 plus. You look here, this is a repeated part. 1 plus 1 divided by 1 plus, it is like this repeating. So what I'll do to calculate this, I'll take this whole value as x. I suppose this whole value as x. I want to calculate this now. I suppose this whole value as x. That means now I need to find the value of x. I need to find the value of x. Correct. Okay. So here, if you observe this, this can be written like this. 1 plus 1 divided by, what is this? This is nothing but continued partner, repeated partner. This I taken it as x now. This whole thing I can write it as x. Okay, I'll write it as x equal to x. Now you simplify this. If you simplify, x plus 1 equal to x square, you will get x square minus x minus 1 equal to 0. I need to find x value. I'll use that formula to find the roots, minus b plus or minus root over b square minus 4ac by 2a. So x equal to minus b. B is minus 1 here. So minus b plus or minus root over b square minus 4ac. B square minus 4ac divided by 2a. 2 into 1. Okay. Further, if I simplify this, 1 plus or minus root 5 divided by 2. So I got two x values here. X equal to 1 plus root 5 divided by 2, 1 minus root 5 divided by 2. Here root 5 value, see, next topic is there, few numbers to remember. Root 5 value is 2.2. 2.2 something, you will get root 5 value. Okay, so here if I write root 5 value as 2.2, 1 plus 2.2, that is 3.2 divided by 2. And you observe this one you observe root 5 value. If I write 2.2, 1 minus 2.2, numerator is negative. We can understand that clearly this is not a negative number, it's a positive quantity. No doubt that in this you will get negative, you won't get negative number. This is 100% positive number. So this is the extra number we got. This is not possible, right? So we eliminate this. This value is less than 0. So this is not possible. Okay. So x value is what? X value is 3.2 divided by 2. Further, if you simplify, 3.2 can be written as 32 by 10. This is 32 by 10 into 2, 20. So 32 by 20 is the value of this continued fraction. This value is 32 divided by 20. Similarly, I want you to find the value of this continued fraction, right? Its answer you will get 2.732, right? Answer also I am specifying here. You can check whether it is correct or not. And one more thing, this course is available on my app very soon. As soon as I'll complete this mathematics chapter, I'll keep this notes over there, and these videos are also over there. And in addition to this notes, my handwritten notes is there. That also I'll include in that course. If you want to encourage these videos, you can purchase the course over there for a very nominal price. I want you to try this problem your own. Prime numbers. Which numbers are known as prime numbers? What are prime numbers? A natural number greater than 1 and divisible by 1 and itself. First of all, prime number is a natural number and it's a greater than 1 and divisible by 1 and itself. For example, you take 2. 2 is a natural number greater than 1. It is divisible by 1 and itself. It is divisible by 1 and itself. If you take the factors of 2, 1 and 2 only, you will get. You take 6. 6 is a natural number greater than 1. It is divisible by 1 and itself only? For this, 2 is also factor, 3 is also factor. 6 is divisible by 2, 6 is divisible by 3 also. So, 6 is not prime, right? What are prime numbers? A natural number greater than 1 and divisible by 1 and itself. Example for prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. It is better to remember up to prime numbers up to 30, right? These are known as prime numbers. Okay. What are composite numbers? A natural number greater than 1. Here also, composite number is also a natural number. It is greater than 1 and which are not prime, right? Which are not prime, right? What are composite numbers? These are prime numbers. What are composite numbers? 1 is a composite number? No, because composite number is also greater than 1. 2 is a prime number. 3 is a prime number. So, the least composite number is 4. 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, like that. These are the examples for composite number, right? Okay, what are coprime? In JEE, related to coprime, we'll find many problems. In JEE previous year questions also, they asked concept of coprime. See, two natural numbers are said to be coprime if highest common factor of them is 1. Highest common factor, I hope you know highest common factor, which is also known as the greatest common divisor. Highest common factor, greatest common divisor. GCD of two numbers is 1, two natural numbers is 1, then we call them as coprime. For example, you take a 5, 9, 5, 9. How to calculate highest common factor of 5, 9? GCD of 5, 9. For that, one easy method is there. What is that easy method? Bigger number you divide with smaller number. Bigger number you divide with smaller number, right? So what you will get? 4. Now further you proceed this. This now you divide with 4, right? Divide with 4. You continue this until you will get remainder 0. Okay, 4, right? 4 ones are 4, right? Remainder is 0. Once you got remainder is 0, whatever the number you got here, that is the highest common factor. So, highest common factor of 5, 9 is what? Highest common factor of 5, 9 is 1. So, 5, 9 are coprime? Yes. Here I will write GCD or highest common factor of 5, 9 is 1. This tells you that the numbers 5, 9 are coprime. Okay. Related to coprime, two important note points are there. If we take two prime numbers, they are always coprime. Suppose you take a 5 and 13. You can check GCD of these two. 5 is a prime number, 13 is a prime number. GCD of these two prime numbers is 1 only. See, bigger number you divide with smaller number. You calculate GCD of 5, 13. Bigger number you divide with smaller number. 5 2s are 10, right? 3, 2, okay. You continue this procedure until you will get 0. At the end here, you see what number you will get here. That is the GCD of these two numbers. So greatest common divisor of 5, 13 is what? GCD of 5, 13 is 1. GCD of 5, 13 is 1. So 5, 13 are coprime. What the point I am trying to say in this? Two distinct prime numbers are always co-prime. Two distinct prime numbers are always co-prime. You take any two distinct prime numbers and you can check their highest common factor or GCD, you will get one only. Okay. Not only that, two consecutive natural numbers are always co-prime. Two consecutive natural numbers are always co-prime. You can check 10, 11. Calculate bigger number, you divide with smaller number. So what is the greatest common factor of 10, 11? That is 1. So two consecutive natural numbers are always co-prime. Two consecutive natural numbers are always co-prime. I hope it is clear to you. What are meant by twin prime numbers? If the difference between two prime numbers is 2, if the difference between two prime numbers is 2, then the pair of numbers are called twin prime numbers. For example, 3, 5, 5, 7. You observe these two are prime numbers and difference between them is what? 2. You see, these are the prime numbers, difference between them is what? 2. These are the prime numbers, difference between them is 2. So these are known as twin prime numbers. 11, 13 are twin prime numbers. Not only that, 13, 11 are also twin prime numbers, right? Difference of two prime numbers is 2. Then the pair of numbers are called twin prime numbers. So related to these prime numbers, what we learned, what are prime numbers? A natural number greater than 1 and divisible by 1 and itself. Composite number, a natural number greater than 1 and which are not prime, which is not prime. And related to prime numbers, what you need to know, two distinct prime numbers are all co-prime. What are co-prime? This point is there, co-prime. Two natural numbers are co-prime if highest common factor of them is 1. This co-prime concept is important for JEE. Related to this co-prime, you need to know these things. Two distinct prime numbers are always co-prime. You take any two distinct prime numbers, they are always co-prime. No need to check like this, right? Two consecutive natural numbers are always co-prime. Okay. Twin prime numbers. The difference between two prime numbers is 2. Then the prime numbers are called twin prime numbers. Okay. Even numbers, odd numbers. What are even numbers? The numbers which are divisible by 2 are the numbers which are multiple of 2 are called even numbers. The numbers which are not multiple of 2, not divisible by 2 are called odd numbers. Usually in integers we use this concept, right? Even integers. What are even integers? 0. First point, 0 is even. Some students have confusion in this. 0 is divisible by 2. 0 is a multiple of 2. 0 is even number. Okay. Plus 2. 2 is even number. Everybody knows that. Minus 2 is also even number, because minus 2 is a multiple of 2. Minus 2 is divisible by 2. Plus or minus 4, plus or minus 6, like this. These are all even integers. What are odd integers? What are odd integers? Odd integers. Plus or minus 1, plus or minus 3, plus or minus 5, like this. These are all odd integers. Okay. Now, important note points related to odd numbers and even numbers. You take two even numbers, if you add them, what you will get? You will get even number only. Not only that, you take two numbers, you subtract them, then what you will get? You will get even number only. You take two odd numbers and add them. What you will get? 3 plus 5. 3 plus 5 is what? 8. Even. If we add two odd numbers, you will get even number. If you subtract two odd numbers, then also you will get even number. Addition of two even numbers is always even. Subtraction of two even numbers is always even. Addition of two odd numbers is always even. Subtraction of two odd numbers is also always even. If you want, you can check 5, 3, 5 minus 3, even. You take one even number and you take one odd number. You add them. 4 plus 3, 7. Odd, right? You add or subtract one even number, one odd number. If you take, if you add or subtract, then you will get odd number only, right? Same thing we'll check in multiplication. You take two even numbers, multiply. What you will get? You will get even number only. Take two odd numbers and multiply. 3, 5, 15. Multiplication of two odd numbers is always odd. You can check this with examples. Multiplication of even number and odd number is even. You can check this with the example 4, 3. 4 3s are 12. Right? So these points you need to memorize while doing permutations and combinations, especially these concepts we use frequently, right? We need to remember few numbers. Order wise we will learn those things. Suppose square of a number 2. 2 square is what? 2 square is 4. Okay. 3 square. 3 square is 9. Right. 4 square. 4 square is what? 4 square is 16. 5 square. 5 square is what? 25. 6 square. 6 square is 36. 7 square. 7 square is 49. 8 square. 8 square is 64. 9 square. 9 square is 81. 10 square. 10 square is 100. Right? Okay. These are the numbers you need to memorize. Not only up to 10 square, 11 square. 11 square is 121. 12 square is 144. 13 square is 169. 14 square is 196. 15 square is 225. 16 square is 256. 17 square is 289. 18 square is 324. 19 square is 361. 20 square is 400. Okay. Not only this, for example, 10 square is there. 10 square means after 1 we will keep 2 zeros. 10 cube, after 1 we will keep 3 zeros. 10 power 4, it is 10,000. After 1 we will keep 4 zeros. 10 power 5, after 1 we will keep 5 zeros. 10 power 5 is 1 lakh. 10 power 6, if anything number is like this, it is nothing but after 1 we will keep 6 zeros, right? That is 10 lakhs. 10 power 6. And here there are few numbers you can easily remember. Suppose 20 square is there. See here 2 square is 4 and you keep 2 zeros. Okay. 30 square is there. 30 square is there. 3 square is 9 and keep it 2 zeros. 40 square is there. You keep 2 zeros here and square of 4 is 16. 50 square is there. 50 square is 2500. Similarly, 60 square. 60 square is 36. 2 zeros, 3600. 70 square is there. 70 square is what? 4900, right? 80 square is there. You first write 2 zeros. 8 square is 64. 90 square is there. 90 square is 81. 2 zeros, right? 10 square is there. First you write 2 zeros and 10 square is 100, right? So 10 square is, sorry, here 100 square. 100 square is 10,000. Okay, right? These are the numbers we may use while doing calculations. If you know these numbers, we can do the simplification faster. Square of a number ending with 5. See, whenever you see such type of things, then you can calculate it faster. For example, 15 square is there, right? Here 5 is there, ending with 5. 5 square is 25. You write that 25 first. And here this 1 is there. After 1, immediate number is 2. So 1 into 2 is 2. 225. Okay. 15 square. 25 square. Square of a number ending with 5 trick we are learning. 5 square is 25. 2 into 3 is 6. 625. 35 square. Right. 5 square is 25. 3 into 4 is 12. 45 square, right? 5 square is 25. 4 5s are 20. Okay. 55 square. 5 6 are 30. After 5, next number is 6. 5 6 are 30, right? 65 square. 65 square. See, after 6, next number is 7. 7 6 are 42. 75 square. 75 square is 25. Is here. After 7, next number is 8. 7 8s are 56. 85 square. that is 25. 8 nines are 72. Okay, 95 square 25. After 9 number 10 is there, 10 nines are 90. Like this, when while finding a square of a number, if it ends with 5, then you can calculate it very easily. Not only this, see, if you want to calculate 23 whole square, you can write it as 25 minus 2 whole square, right? 25 whole square, that you can calculate very easily. Plus 4, a square plus b square minus 2ab. 2 into 25 is 50, 50 into 2 is 100. 625 minus 100 is 525, 525 plus 4 is 529. Like this, you can calculate. Similarly, 25 square you want to calculate. 28 square you want to calculate. 28 square can be written as 25 plus 3 whole square. Not only that, you need to calculate 103 whole square. 103 whole square, you can write 100 plus 3 whole square. Or else you want to calculate 97 whole square. That can be written as 100 minus 3 whole square. In this way also, you can calculate square of a numbers quickly. As we are doing basic mathematics in number system, I know you know all these things, but still it is important. These things are important. To know these things are important. See, this 110 square is there. You write two zeros. 11 square is 121. Okay. 120 square is there. You write two zeros. 12 square is 144. 130 square is there. 130 square is what? 16900. Right. 150 square is there. 15 square is 22500. Right. Not only these things, square root of a number. See, the root 2 value is 1.414. Right. Root 3 value 1.732. We use these numbers directly while solving the problems, right? It is important if you know these values. Root 4 value, obviously you know, root 4 is 2. Root 5 value is 2.2. Root 6 value is 2.4. Root 7 value is 2.6. Root 8 value is 2.8. Approximately I am writing. Root 9 value is 10. Root 10 value is 3.1. Okay. These numbers may useful while solving the problems if you can remember. Okay. So this is square root of a number. Now cubes. Cube of a number. 1 cube. This is simple. 1. 2 cube. 2 cube is 2 into 2 into 2, that is 8. 3 cube 27. 4 cube 64. 5 cube 125. 6 cube 216. 7 cube 343. 8 cube 500. 9 cube 729. 10 cube is 1000. Right? Cube of these numbers, if you can remember 11 cube, 12 cube, 13 cube up to 20 cube is very good, right? These are the cubes of a numbers we use frequently while simplifying. Multiplying a number by 11. For example, 12 into 11 you want to calculate. Very simple. This 1, 2 is there. Na? You write like this. 1 plus 2 is 3. So, 132. 25 into 11. You need to calculate this. 25 is there. Na? You separate them. 2, 5. 2 plus 5 is 7. 275. Right? 45 into 11. You write 4, 5 separately. 4 plus 5 is 9. Like this, any number multiplying with 11 is easy. Okay. And you see one interesting factor here. 11 into 11. Okay. So here 2 ones are there. Na? 1, 2 and write decreasing order. Right. Suppose it is like this. 3 ones are there. 111 into 111. Total 3 ones are there. Na? 1, 2, 3. Because 3 ones are there, and then start writing decreasing order. Okay. Suppose it is like this. It is like this. 4 ones are there. Na? 1, 2, 3, 4 and then start writing decreasing numbers up to 1. Suppose 5 ones are there. It is like this. 1, 2, 3, 4, 5, 4, 3, 2, 1. So you can continue like this. Okay, so I hope you understand this trick. Few important things, this also comes from number system. Divisibility rules. When we say a number is divisible by 2, when we say a number is divisible by 2, if the last digit of that number is even number, right? For example, 2, 4, 5, 6, 8. Is it is a even number or not? How you will decide? Units place is even number, right? Last digit of the number is even. Okay, that number is 100% divisible by 2. Okay, when we say a number is divisible by 3, when we say a number is divisible by 3, sum of digits is divisible by 3. If the sum of the digits of number is divisible by 3, then we say that number is divisible by 3. Suppose 1428. This is a 4-digit number. Is it is divisible by 3 or not? Just add all the digits. 8 plus 2, 10. 10 plus 4, 14. 14 plus 1, 15. Is 15 is divisible by 3? Yes, 15 is divisible by 3. So, 1428 is 100% divisible by 3. Okay. Divisible by 4. When we say a number is divisible by 4, number formed by the last two digits is divisible by 4. For example, 144 is there. Is it is divisible by 4? Last two digits are what? 144. Sorry, 44. 44 is divisible by 4. Yes, 44 is divisible by 4. So, 144, 100% divisible by 4. Suppose something like this, 1, 2, 3, 4, 2, 4, something like this. Is this number is divisible by 4? You just observe last two digits. If this last two digits are divisible by 4, then this total number is divisible by 4. Is 24 is divisible by 4? Yes, 24 is divisible by 4. So, then this total number is divisible by 4. When we say a number is divisible by 5, last digit of that number is either 0 or 5. Then we say that number is divisible by 5. For example, 1, 2, 3, 4, 6, 7, 8, 0. Is this number is divisible by 5? 100%. If units place whatever the number is there, if that is either 0 or 5, then that number is divisible by 5. Okay. When we say a number is divisible by 6, if it is divisible by both 2 and 3, then we say that number is divisible by 6. Suppose this number is there, 144. Is this number is divisible by 6? First point, as units place is an even number, then this number is divisible by 2. And is this number is divisible by 3? You add sum of digits 1 plus 4 plus 4 is 9. 9 is divisible by 3? Yes. This 144 is divisible by 2 as well as 3. So 100% this number is divisible by 6. You see, number is divisible by 7, right? Last digit is a multiple of, see how we decide a number is divisible by 7. For this, little tricky steps are there. You observe last digit of that number you multiply with 2, okay, and subtract. After multiplying with 2, whatever you will get, subtract that value from the remaining part. After subtraction, whatever the result you will get, if that number is divisible by 7, then the total number is divisible by 7. I'll explain this with an example. You take 343. I am checking that is this number is divisible by 7 or not. I just taken a number 343. I taken a number 343. Is this number is divisible by 7 or not? For that, what you will do, this last digit is there, na? That you multiply with 2. So step 1, here I'll write step 1. What is that last digit? 3. 3 into 2 is 6. Okay. Step 2. What is step 2? Remaining, subtract that value from the remaining part. See, in 343, remaining part is what? 34, right? 34 minus 6. 34 minus 6 is what? 28. Step 3 is what? The result is divisible by 7 or not. That means here what is the result? 28. 28 is divisible by 7. 28 divided by 7. 7 fours are 28. Yes. 28 is divisible by 7. So 343, this number is divisible. This number is divisible by 7. This number is divisible by 7. Like this, you can check for other values. This is a bit tricky. As the number is bigger, it may difficult, but however, we have this result, right? How to check a number is divisible by 7 means we will follow these 3 steps. Okay. How to check a number is divisible by 8? The number found by last 3 digits of that number is divisible by 8, then we can say that that number is divisible by 8. When we say a number is divisible by 9, sum of all the digits of that number is divisible by 9, then we can say that that number is divisible by 9. When we say a number is divisible by 10, if the last digit of that number is 0, then we can say that that number is divisible by 10. When we say a number is divisible by 11, sum of even digits minus sum of odd digits, that means difference of sum of even digits and sum of odd digits is divisible by 11, then we say that that number is divisible by 11. See, knowing these results are important. Based on the situation, we don't know, especially in permutations and combinations, we use these tricks very frequently. Some useful mathematic symbols. See, for every, this is the symbol of for every, for all. I'll write here for all, or we can read it as for every, right? How you use this symbol? Suppose while writing a set representation, we will say like this: x such that x is less than 4 is something like this, man. X plus 4 is greater than 1 for all x belongs to n. N indicates natural numbers here. Suppose you saw one equation like this: x plus 4 greater than 1 for all x belongs to n. This symbol is what? For all. That means in this, whatever x is there, for all x belongs to n means x value can be 1, x value can be 2, x value can be 3, like that. X value can be any natural number for all. Okay. Next symbol is there exists. See, this is the symbol of there exists. How we use this symbol? See, for every x belongs to R is a real number here. There exists, you see the symbol, there exists y is also real number. Y belongs to R, this symbol is belong, this also we need to discuss. Y belongs to R such that general meaning such that xy equal to 1. So here what it tells you that for every real number x, there exists another real number y such that xy equal to 1. So in mathematics, you will see such type of equations, especially in functions chapter. Whenever you see such type of things, how you read this? How you read this? We read this: for every x belongs to R, there exists y belongs to R such that xy equal to 1. Okay. General meaning, general in English, what way we use, same like that. There exists. Okay. Next symbol, you know this. This is less than, strictly less than, right? Less than. We use this symbol to represent the inequality between two numbers. Suppose 2 is less than 10. They'll say x is less than 10 for every x belongs to n. Something they given like this. You need to take all natural numbers which are less than 10. Okay, less than. Obviously, when less than is there, another symbol is also will be there. What is that? Greater than. Okay. This symbol is less than or equal to. Less than or equal. This symbol is greater than or equal. Greater than or equal to. Right? This symbol is belongs to. Belongs to. Right? Suppose I'll write like this: x belongs to n. That means x is a natural number. That means what x can be? 1, 2, 3, 4, something like that. Or else I'll write like this: x is a real number. What x can be? X can be any number in between minus infinity to plus infinity. Right? Belongs. Does not belongs. Does not belongs. x does not belongs to natural number means x is not a natural number. Next symbol implies. This we also read if then. Implies very simple. X plus 4 equal to 1 implies x equal to 3 minus 3. X equal to minus 3, right? See here, this is what if x plus 4 equal to 1, then x equal to minus 3. Instead of if then, what we used? We used only the symbol implies, right? Suppose x plus 2 equal to 1, then implies x equal to. This imply symbol is nothing but if then, right? Implies and implies, implies and implied, implies and implied by, implies and implied by. This symbol is implies and implied by, or simply we write it as if and only if. Or it can be written like this also. This also we read it as if and only if. See, this is like two-way. For example, AB equal to 1 implies and implies B equal to 1 by A. That means when AB equal to 1, B equal to 1 by A, when if and only if symbol is there, this also we can use. What is this? If B equal to 1 by A, then AB equal to 1. If B equal to 1 by A, then AB equal to 1. If and only if. Implies and implied by. Okay. Next notation is summation of. This symbol is there, na? Sigma. This symbol is summation of. Suppose ABC are the three variables. ABC are the three variables. If they mention sigma A and they mention there are three variables, sigma A indicates A plus B plus C, summation sigma A. And if ABCD are four variables, if they mention there are ABCD four variables, then sigma A indicates A plus B plus C plus D, right? Suppose ABC are three variables, sigma AB indicates AB plus BC plus CA, right? Sigma indicates summation. If they mention ABC are three variables, then only sigma AB is AB plus BC plus CA. Okay, next product. Same like the sigma A, this is like a pi symbol. Product of, this indicates product of pi A if they mention that, and ABC are the three variables, then this is A into B into C. Product of, the symbol indicates product of, right? Next, nth root of some x. Nth root of x. Square root, you know, square root is what? Square root of x is what? It is x power 1 by 2. Cube root of x is what? X power 1 by 3. Nth root of x is what? X power 1 by n, right? Next one is factorial notation. You see like this, n factorial. N factorial is defined as product of first n natural numbers. That means n factorial is 1 into 2 into 3 into 4 into and so on, like this n. Product of first n natural numbers. The same thing you can write from the reverse order also, as it is a product. We will start with n. Next n minus 1. Next n minus 2. N into n minus 1 into n minus 2 into and so on. 3 into 2 into 1. Both are same. N factorial is product of first n natural numbers. Suppose 5 factorial is there. How you will write 5 factorial? 5 factorial is product of first 5 natural numbers. We will start with 5. 5 into 4 into 3 into 2 into 1. 10 factorial is there. 10 factorial you can write like this. 10 into 9 into 8 into 7 factorial. 7 factorial indicates what? Further continuation. 7 into 6 into 5 into 4 into 3 into 2 into 1. Like that. I hope you are understanding. Okay. 0 factorial. What is 0 factorial value? 0 factorial is defined as, see, n factorial is product of n natural numbers, correct. 0 factorial, that definition doesn't work for this. This is the special case. This 0 factorial is defined as 1. This 0 factorial, they defined it as 1, right? Okay. So these are the things we learn from this number system topic.